Okay, so this is the code for regression and correlation, or just very basic code. And what I'm going to do is go through um, the code, how things go together, how to run it, et cetera, how to make plots, and write an example APA um, formatted summary of those results. So again, we will go to the regression code in R and R Studio. And so again, what you'll see here is this is an example out of a one-way of ANOVA of width of regression and correlation. And with an example write-up, what you'll want to do is make sure that you download the regression data here, and also make sure that you change your working directory for the overall file in line 12. Okay, you'll also need these similar libraries as before, so you should have those downloaded. So let's start. So in this example, someone's asked you to predict IQ from measurements of brain size, height, and weight. And so we're going to create a multiple regression to do this, mostly because we know that predict gives us regression or some kind of model, in this case, a linear model. And just know that like these data are made up, brain size, height, and weight are not really predictors of IQ, at least not from this data. There may be data out there that says that, but this is completely made up. So kind of assume for this data that this brain measure refers to some continuous measure of brain size, like as calculated by an MRI. Height is the height in inches, and weight refers to an individual's weight in pounds because we're United States centric. And before we predict this, we're just going to do a bunch of correlations for each of the two variables, or for each variable, so you can see how you would run kind of a correlation matrix as well. Okay, so first thing we'll do is we'll just go ahead and bring this data in using the read command, read.csv. And what's really nice, and what you'll see, and actually let me clear this out of here. We have a lot of stuff here from last time. Let's do this again. Read the data in. We've got 38 observations where we have IQ, a brain, a height, and a weight number. Okay, so all continuous measures, we're going to predict one of them, but because they're all continuous, we want to think, oh, that's not analysis of variance, and we're predicting, so that's got to be some kind of regression. And I'm going to do a multiple regression because the single regression is really just a correlation. So most often we're going to use some kind of multiple regression. And the other thing that I'm going to do here is I am not evaluating that model. I'm not testing assumptions. I'm just simply showing you how to get started by running the model, and model evaluation sort of comes later and as a topic in and of itself. So we're going to kind of ignore that for here and just learn how to make sure that we can get started. Okay, so the first thing we can do is we can just use this plot command to do scatter plots of all our correlations. I think this is one of the coolest thing R does because it gives you this really nice picture that allows you to visualize the relationship between IQ and brain, IQ and height, IQ and weight, brain and height, blah, 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 okay? So you can just look at this and I might think, well, some of these looks kind of random, like this one's a pretty random value, but this one over here, it looks pretty straight. That looks cool. That kind of makes sense, right? Like height and weight are probably pretty related. There might be a line here, maybe a line here, here, here. So this gives you like a nice way to start thinking about the individual relationships between these variables. So good visual. So if I notice maybe that height and weight look like they could have a line drawn between them pretty easily, maybe I want to test that individual correlation and see if that is a real thing beyond our visuals. Well, we can do that. There's this function here called core test, and it's a pretty simple function. All we do is we say, what's our first, oops, what is our first variable? What is our second variable? Give us the results. Remember, correlation is just pairwise. So let's see how this looks. And let's spit it out. And it gives us a nice reporting of the results. This line here gives us our t-value, our degrees of freedom, our p-value. We have our confidence intervals, and then we have our R, the level of the correlation down here. Okay, so this is a pretty simple test. And what's nice about it is that you can use this, this write-up that I have below to add those values in. So if we look at our write-up here, we have a Pearson correlation found that there was a relationship. That relationship was significant and positive, and we're going to put the t-test value in there. We're going to put not the t-test value, the degrees of freedom there, the t-test value here. I wrote in the p-value, and then the correlation estimate there. So we can use R code to just put all of those in. The other thing that we might want to do is we might want to show a scatter plot of that relationship that's a little bit more in detail than the other one we showed. So here, we're going to use the scatter plot command. We're going to do height versus weight, our variables, and what the data is. And then there's a couple commands here or extra things that you can add in. So you can put in these bot plots and smoothing functions just to kind of give us a little bit of more information about how successful we were in estimating the correlation. Let me show you what this looks like. You could turn all of those to false or F if you wanted to, and you would get a graph that looks more like something like that, like this. And you'll see how that differs from what this looks like here in a second. So here we have a little bit more information about the quality of our estimate. This is our linear regression line right here, or our R value. And then these dotted lines here are smooth confidence intervals, basically. Okay, so this is just a slightly more reflective graph. I like it. Often we don't show a graph for correlations anyway, but I thought I would put it in there so you could see it. Okay, and now for our multiple regression, what we're going to do is we really want to predict the IQ from these other variables. Again, our formula is pretty simple. We're going to use LM. LM stands for linear model. And we're going to say, all right, well, what is our IV? Or our predict, IV is probably a bad way, but let's say linear model, and then this is our predicted thing. It's really more of like a dependent variable, but this is our predicted. And then squiggly line. And remember, a linear model or a multiple regression is just adding stuff together, right? Slopes or relationships plus variables. So we have our like IV1 plus IV2 plus IV all the way to however many we have. Okay, and I wrote this as a reminder right here for you. So in this case, we're going to say our formula for the linear model is IQ as a function of our 3 predictor variables. And what data do we do this on? We're going to do it on whatever we called our data, which for me, I like to call data. Okay, so let's do that. And we'll check out what the results look like. Here's a summary of our results. And there's a bit of information here, so let's just go through it. So what we're going to do is, so these residuals, we want these to be approximately normally distributed. There's ways of testing this. This looks pretty okay for right here. You guys for class can kind of ignore this. And then we want to see what things are individually predictive of the relationship between IQ and these predictor variables. So this is your equation. if you were going to like write it out. And we can do that with this t-table. And basically what we're going to do is for each predictor, we're going to see, well, what is the t-value and what's the p-value? This is what we care about here for now, okay? We also care about, so this is for predictors. And then down here, this is for the overall model. So remember with regression, we care about, does the overall model work first? And if so, what are the predictors that help? So this is number one, and this is number two in how we sort of look at things. But those are the places, okay? So what we care about is if our model, how much variability our model accounts for, if it's significant. So here's our F test. So our F 3,34 equals this 4.71. The p-value is less than 0.05. So this is significant. Our model works. Give it a check. And the other thing that we care about is how much variability it accounted for, which is this R squared number here. It's a longer conversation about multiple versus adjusted R squared. Either one is fine for the purpose of class. Okay, so here we're going to say, I'll use the adjusted R squared. We're going to say, okay, well, our model accounted for about 23% of the variability. And we get all of that information from that little paragraph down here. Let's look at how I might write that, just that piece up. So here we're going to say the overall model was significant. We wrote down the p-value. We talked about the variability. Here I used a multiple R squared instead of adjusted R squared. Again, just have to tell me which one you use. And that's going to be how we summarize this piece of information. Next thing we need to do is say, all right, well, what individual things were predictive within that model? The model works great, but what are the actual predictors? And so this next set of sentences here tell us a summary of this. And what we see here is that we can ignore this intercept, but we can see that brain and height are the two predictors because those are less than 0.05, and then weight doesn't matter, 0.99. So let's summarize those, and we'll just say, okay, well, weight's not a significant predictor. Here's the p-value, but brain size and height are, and for each one of those, we want to add in the t-value, the degrees of freedom, and the p-value. Again, we get these degrees of freedom from this 34 here. Okay, we can use that for all of them. The next thing we need to know that we haven't figured out yet is like, which one is more important, right? So let's take a look at what our betas are, right? And we can use this function called standard coefficients, and we'll go ahead and put our results from the linear model right into that function. And we'll say, all right, well, give us the regular betas and then the standardized betas, and we want to report one of those. I typically like standardized betas, but again, it sort of depends on your research question. You can do both here. So here's our betas. So here is our regular betas, and here's our standardized betas. Again, what I like about standardized is this allows you to compare them and see which one has a stronger relationship. So remember that weight didn't matter, so we can just think of this as crossing that off completely and just reporting for brain and height, which is what we do down here. And since we've called this a particular variable in R, we can then go back and say, well, just report out to me what that number is. I don't have to type it in by using inline R code here. Now, I haven't made a figure for this because really what we care about is those numbers. Often you might see these parameters in a table instead of in this kind of format. R doesn't make that super easy for you. So for here, we're going to just report out those numbers. And if you had many predictors, you'd probably want to put them in a particular table or lots of different models or something like that. So that's a little bit beyond the scope of what I want, of what I care about for class right now. So instead, we're just going to leave this in written form. So let's go ahead and knit this document, Control-Shift-K, and take a look at what it looks like if you wanted to send it to somebody who didn't have R or didn't use R. So here again, we'll see that I've left some of this code up for you so you can see it, but you don't have to do that. Here we have our nice pretty picture of all the different correlations. Then we're going to do a correlation write-up. Here's our figure for that, as well as our actual write-up here. And then here's our code for multiple regression. Here's all of the output. And then here's our write-up with all of those numbers called for you. Okay, so regression is slightly simpler, I think, to write up. There's not as much figures or whatever, but I think the harder part here is really making sure to know how you get from, this box to the write-up. So hopefully this particular video has helped make that a little bit more clear for you. And again, as always, let me know how I can help.